Think of Layer 4 protocols as two contrasting delivery services. TCP is like a premium courier service that ensures your package arrives intact, even if it has to take a detour through multiple cities. UDP, meanwhile, is the budget-friendly service that just drops your package on the porch and zooms off, no promises made. Knowing when to splurge on the luxury courier and when to opt for the economical choice is key for passing the CCNA and creating networks that function properly. Picture TCP as a formal dinner party. Before you even get to the soup, there are all these introductions and handshakes. TCP kicks things off with a three-way handshake to make sure everything's in tip-top shape before any data starts flowing. It's like having assigned seats for every single byte. Each one knows its exact place. TCP waits for acknowledgements, resends any lost data, and keeps the flow steady so the recipient doesn't end up with data overload. Now, compare that to UDP, which is like a food truck. It skips the whole reservation and seating arrangement business. UDP just sends packets flying into the world without any fuss. No setup, no checking if they arrived, and no resends if they go missing. Sure, it might not win any awards for reliability, but it's all about speed and simplicity. Think of it as the fast food of networking. Imagine you're at a party and you want to start a conversation with someone. First, you give them a nod to get their attention. That's like the client sending a SYN packet to the server saying, "Hey, I'm ready to chat." The server notices your nod and nods back while saying, "Gotcha, I'm ready to chat too." That's the server responding with a SYN ACK, acknowledging your request and sending a greeting of its own. Finally, you give a thumbs up to seal the deal with a perfect, let's talk. That's the client sending an ASIC back to the server. With this three-step dance, both sides know they're ready and in sync. And just like that, the real conversation, or in this case, the actual data transfer, can kick off. Streaming a video, making a VoIP call, or jumping into an online game, you're likely riding on the back of UDP. Now, picture TCP handling your video stream. You miss a packet and TCP's all like, "Hold up, we've got to resend that." Result, your screen freezes right when you're reaching the good part. Frustrating, huh? UDP, on the other hand, just lets that little hiccup pass by. It keeps cruising along while any mistakes get ironed out at the application layer. And when it's time for DNS queries, UDP is your best friend. It's like a quick chat, just a simple request and response, without the fuss of a TCP handshake slowing things down. Picking between TCP and UDP is like choosing the right ride for your trip. Imagine you're transporting a truckload of eggs, fragile, precious cargo. You'd want to ensure every egg arrives in one piece, even if the journey takes a bit longer. That's TCP for you. It's the go-to for file transfers, web browsing, and emails, where losing even a single packet is a no-go. Everything needs to arrive perfectly. Now, if you're just zipping to the store for milk, you might hop in a speedy little car. Sure, you might hit a few bumps, but you'll get there fast. That's UDP. Think of DNS queries. It's just a quick question and answer. No need for extra fuss. Streaming videos and VoIP calls are the same. Speed is the priority here, not perfection. It's better to miss a couple of frames than have a delayed conversation. And then there's TFTP, which uses UDP because it's like a traveler with just a backpack, handling reliability on its own. It's simple, straightforward, and doesn't need a lot of extras. 6 TCP and UDP quirks that love to trip up exam takers. First, DNS typically uses UDP, but when it comes to zone transfers or when responses are over 512 bytes, it switches to TCP. It's like expecting a simple coffee and suddenly getting a full breakfast spread. Next, TCP windowing is the receiver letting the sender know how much data it can handle, serving as flow control. It's not the same as congestion control, which is a common mix-up. Think of windowing as a bouncer at a club, letting people in based on the space inside, not the line outside. Ending a TCP connection isn't a three-way handshake, it's a four-step dance. FIN, ACK, FIN, ACK. It's like saying goodbye twice to make sure the door is definitely closed. UDP has an 8-byte header, whereas TCP boasts a 20-byte minimum. Both protocols rely on port numbers to keep everything in check, just like room numbers in a hotel keep guests organized. Here's a classic gotcha. TCP sequence numbers track bytes, not segments. So you're counting pages in a book, not chapters. Keep these quirks in mind, and you'll be cruising through the exam. And that's the tale of TCP versus UDP, a battle between reliability and speed. We've covered the three-way handshake, flow control, and why your favorite apps pick one over the other. If you're hungry for more CCNA practice questions, swing by Courseiva.com. Keep at it. You're doing great.